Thank you, sir, for that observation. So I need to start all over again. Okay, no need. Let's just continue. So energy auditing. Basically, three things an auditor has to know or has to do. Number one, you must have that knowledge to be able to identify the energy saving opportunities. Then number two, you need to have the knowledge on how do you quantify them? What parameters do you use? What knowledge level do you need? What are the code? What are the terms? What are the terminologies? Okay. And then finally, you now have to report them. Report them in a layman's language, in a way that management will understand and buy into it. Because the job of the energy auditor is not just for you to work, but it's for you to achieve results. So it's one thing to come into a facility, you know how to save energy, you know how to reduce your energy bills, but you might not have the expertise to report it in a simple, coherent format that a manager who is not an engineer, without having to crack his head what you're talking about. And that is where some of the reporting method comes in. Okay. So in energy auditing, there are different standards. There are different standards of doing energy auditing. But all of them, some of us who know about code and standard, we know that they are virtually the same thing. Take, for instance, if the German says that their standard of safety for dam is 2.5, the French will tell you their own is 2.55. I mean, it's just the same thing. So irrespective of the standard you are using, which of course we're here to develop our own standard in Nigeria, they all have virtually the same process. They speak about the same thing. Understand? For instance, if you are talking about EN standard for the steps to be taken by an engineer to perform an energy auditing, that is what you have on your right, on your left, sorry. And based on ISO standard 50002 is based on your right. So if you're looking at these two standards, you practically not see any difference because they're just the same thing, just an improvement over another one. In the EN standard, EN 16247, which is European standard, is more of the first step of an energy auditing is your preliminary contacts. First of all, you make a contact with the manager, with the CEO, with the human resource, or whoever is in the position to speak on the energy architecture of the company or the facility. Then the second thing is that you set up a startup meeting. Okay, you've made up the primary contact, you've told him about the need for them to save. I mean, you've asked him how much you pay for energy bill in a month. He says, oh, we are paying 2 million naira. You say, I think we need to work a way to reduce it to 1 million. He said, wow, okay, come and make your presentation or come and tell us why. Okay, so the next thing you do is to initiate a startup meeting. You set up a startup meeting with the management or with the management and staff, whichever one fits. Okay, now in the startup meetings, you must make sure that somebody from the topmost management level is around, probably the CEO or the owner of the company. Then you also make sure that those people who are important to the energy flow in that organization are also around. And sometimes we even tell you if it means a man taking record of the details, you have to be around. Sometimes it could be the man who takes stock. Sometimes it might even be the security man. If you know that this person is important, is needed, then that person has to be around. Then after the startup meeting, you agree on the modalities of how to proceed, the day, what you need, people that you want to work with you in the team, just like a typical audit process if you have contact. The next step is data collection. Read what and what not. You've agreed on the company's safety procedures. You've agreed on which staff is going to work on your team. Probably you've agreed on how much you'll be paid. most times you might not ask for money, but when you are doing your reporting, or when you are about giving your final audit, your bankable or your level 2 audit, you can now request for payment, but that is flexible anyway. Then after your data collection, you now go for field work. So data collection and field work can be done interchangeably. Okay, you can collect data, you can go back and install some energy meters, you come back, okay, you look at the ratings, you didn't capture some things, you send back. You can even station somebody in the facility to take record of day-to-day energy consumption, so that you can establish your baseline. Okay, because most times baselines are very important. You need to know where are we and where do we want to be. So in establishing your energy baseline, you might have to move back and forth between field work, analysis, and data collections. Okay, so after data collection, you move to the field work. Okay, you've collected data, maybe their energy bills, how much they pay per month. Then you move to the field, okay, to take data and look at the machines, the facilities, the equipment, and correlate and see if there's any correlation between what they are paying and what they are consuming. Then you can also fall back. The next step is for you to fall back and then do an analysis of what you have done using the knowledge that you're going to acquire from this training. Because that is where the knowledge comes in. The first 4 steps are something everybody can do. But the 5th step, 5.5, is something that somebody who have passed through a rigorous training will understand the formats, will understand the procedure, will understand what comes first, will understand how to rate the energy consumption of a compressor, of a boiler, of a motor, of a HVAC system, of a lighting system, and then come up with the energy saving opportunities. Remember what I said at the beginning. There are 2 ways you can save energy. You can save energy through energy conservation. All of us know what it is as engineers. You can conserve energy. Okay? Instead of boiling hot water for 2 hours, you can set to boil it for 1 hour. Instead of using a 20 kg jug to boil a water of 10 kg, you can as well buy a 10 kg jug. Waking up in the morning and offing your security lights by 6 a.m. is an energy conservation measure. Okay, reducing the temperature of your AC from 18 degrees to 24 degrees or 22 degrees will save you a whole lot of energy. So these ones are more of energy conservation measure. It costs nothing. It doesn't cost money. And that's why we call them energy conservation measure. But there's another part B, which is now implementing energy efficiency measure. Those ones are now capital intensive. So there are 2 ways you can save energy. And the energy efficiency measures will now include those ACs that I bought 10 years ago, those refrigerators that I bought 5 years ago. I know now their energy, the energy usage is high. One typical example I would say is LED TVs. I remember those days, cathode ray TVs will consume up to 400 to 500 watts. But believe me, most of the LED TVs today can cost as little as 50 watts. I don't know what the high definitions are doing now, but the thing keep going down. The latest air conditions in the market now that have star ratings are consuming 50% of what the old ones are consuming. So if you now recommend the measures that will involve replacing old systems with new ones, that is now where that's where energy efficiency measures comes in. So always have this at the back of your mind, that not all energy efficiency, not all energy saving opportunity involve cash, involves money, involve cost. Some of them are just some simple house rules, household keeping, just conservation. Then, after your analysis, you now do your reporting. In the course of this training, we're going to give you 1 or 2 templates of how to report your work. Now, let me say this. Most of our engineers have problem with reporting their work. And this is one area we need to work on. And let me also advise, sometimes you don't need to invent the wheel. All you need to do is to consult somebody that have done something like this before, get that template from the person, and then leverage or edit, basically. So I'm going to give you now some energy reports and some guidelines in the course of this training. And then you know how best to report it. Sometimes you have to go and do some work in Excel. Sometimes you have to go and download some pictures, get some videos, play it to them. Tell them why if they operate this machine at level 5, it will consume less energy. Then finally, you now have your final meetings. Your final meeting could also be in form of your startup meetings. In your final meetings, you now call management and say, look, I've gotten a gold mine. Oh, come on, guys, we can do this. We can implement this. The payback period is 2 years. The payback period is 3 years. Come, we're going to do this. And there will be Christmas bonus. If we achieve this, Oga is going to throw party. Because if Oga is saving 5 million per annum, I mean, it won't be a bad idea to throw out 1 million for the boys and probably another 1 million for the auditor. Okay, so that is that. So now, looking at ISO standard also, you find out that what we just said now is almost the same thing. There's not much difference. Okay, you also start with the difference that in the ISO standard, in place of preliminary contact, you start with what we call energy audit planning. In other words, you need to plan. You now fall back to what we said before, opening meeting. From opening meeting, it could also be the point where you collect data. Then after collecting data, you go back to site and do measurement, have your measurement plan, your field work from the EM standard. Then after your measurement plans, you now conduct a site visit to the facility, okay, to the manager's office, to the production plant. You conduct a site visit. Then after the site visit, you now go back to your office, go back to your system, and now do an analysis of your findings. Okay. Then after your energy audit reporting, you now conclude with a closing meeting. So one thing I want to point out here is that it might look simple, but each of these steps, each of these group have other things you need to apply. Okay, the close-up meeting could be presenting a chart. You could present a PowerPoint. You might even present some proposals of how the energy saving, the money that's going to be saved will be reinvested in the welfare of the workers. I mean, nothing is cast on stone. You have to come up with your own initiative on how you want to close up the whole process. But having a close-up meeting is important because it's in that close-up meeting that you need to bring everybody on board. Now, let me say this. So some of us have done audits in other areas. Auditing is a controversial thing. Many people don't want auditing because some people view auditing as an opportunity to expose their little secrets. Okay? So as the energy auditor, you need some level of pragmatism. You need some level of added management skills that are beyond this course, I must say. But it's good that I tell you about it, which is what we agreed at the beginning, that this training is not just to show you, maybe because I'm an expert, no, but let's go learn. And I believe during the question and answer session, some of us that have had these experiences of auditing other things that is not energy will tell us some of their challenges, how they're able to overcome it, and one or two things we can take home. Okay, so what is the goal of energy auditing? We say, so now I'm not going to read slides. Anything that I know you read and understand, I'm going to skip it. I'm going to skip it because at the end of the day, all of you are going to have this. So you're going to read them. I don't believe in reading PowerPoints. Okay, so these are the goals we want to achieve. Okay, identify the time and the cost of energy. You must do it. You must have energy history. Okay, you must benchmark and you must establish African auditing you. So before you start your energy auditing, you need to know the auditing process. You should be able to say, this is what we're going to spend. This is what we're going to save, sorry, because it's all about energy savings. Then you need to understand how the energy is being used and wasted. This is very important. In most people, when they leave office, they leave their ACs on. In many hotel rooms, when clients check out, believe me, the television will be on. Everything. Some hotels now applying energy efficiency by having this automatic key, whereby if you enter your room, your light comes up. If you leave there, your light goes out. I mean, these are all measures, and more will come. And then maybe when you check out, a staff will go and inspect the room and off all the lights. Now, if you didn't educate your staffs, if you didn't tell them about this, when somebody checks out, they'll just pick the key and put it on the cupboard. Okay. Somebody said my voice is cracking. Can I have a confirmation of that? Ebenezer, is it still cracking?
Yes, it's cracking. It's cracking.
Okay. Maybe my earpiece has issue. Or how about now?
It's a bit clearer now.
Oh, it's cracking badly. Okay, I'll remove the earpiece. Can you hear me now?
Yeah, I can hear you now. We can hear you. I can hear you.
It's better now.
Yeah, it's better
so,
now. Yes.
I've done away with the earpiece. Okay. Oh, you would have said this all this while. Thank you. Now, the other goal of energy auditing is for you to identify operational techniques. Where do they need new equipment? Where do they need new technology? These days, in Germany, for instance, now, if every department will have an energy meter, that's cool. So at the end of the day, you know what everybody's consuming. In a public yard, those days, people have 1 meter, and somebody somewhere blowing off all the energy. But now, if everyone has a meter, if everyone is metered, then everybody will sit up. So these are things you might introduce. Okay, the goal is also to perform an economic analysis. Okay, on those alternatives. Sometimes you have options. You come up with alternatives, 1 or 2 alternatives. See, this is how management can do this, or they can do this. So at the end of the day, you don't just say A is better than B indicators. You must prove it that this route will save ₦1 million in the next 2 years. Why this route will save 200,000 in the next 2 years. There must be some measure of economic operation, and that is why economic analysis is part of this training. Because at the end of the day, it's about the number. It's about numbers. Do we have the numbers? What are the numbers saying? Okay. Then the next one is to develop an action plan. Maybe you can develop an energy policy for the company. Then you develop timelines, you develop budgets, and how to implement them. Okay. So what are we have 2 energy auditing procedures, energy auditing categories. We have the internal auditing and you have the external auditing. So this auditing have their pros and their cons. Internal auditing is when a member of the same company, this member of the same place is the one carrying out the audits. The external auditing is when you have a third party, an expert like you, who has been consulted to do the auditing. Now, what are the pros of the internal auditing? Well, very simple. Number 1, he's already familiar with the company processes. He is already familiar with the production processes. So he knows where the things are, where the energy, he knows where to find the energies, then the energy losses. Then he knows what level of data is available because he's part of the system. Then sometimes he's not paid because it's cost effective. I mean, you're part of the system, you're doing it to help the organization or to help promote some kind of management policy. Then, what are the disadvantages? They will see it as business as usual. In fact, some will not give you respect, some will not give the corporation. In fact, some will see it as you are busybody, or you're trying to invade their space, then you are less likely to ask critical questions. I mean, there are some questions you don't ask management how much they are spending paying energy bills. I mean, it's like you're overstepping your bound. Yes. Then the quality of your output, because you're not being paid, because you are part of the system, probably because you're not also well trained, there's every tendency that the quality will be very poor. Then we move over to the external auditor, which is what we're training some of us to be. The quality is of higher standard because you mean business, because you've gone through this training, because you've been mentored, you've been trained. So your quality, your output will be top notch. Then, because you've been engaged formally, there's every tendency that you're going to ask critical questions. You're going to ask questions without minding whose horse is being God. Because you are here for something and you want to prove a point. Then your questions will be based on your exposure, will be based on your outside view. You'll be able to ask any kind of question. And those questions are questions that will aid you in coming up with a practical solution and a beautiful report that will make them pay you. Okay, the chairman of NSC, Maitama, is around. He's sending his greetings. You can go to the chat box. Soon, when it's time, we'll call him up to say one or two things. My chairman, when you're ready to talk, you can inbox me or let me know, or tell the technical secretary. He will reach out to me. Then we can allow you to say something. We waited for you, but we couldn't see you. We'll have to start. Thank you. Okay. Now, what are the disadvantages of external auditing? It's less cost. It's expensive. It's expensive. Yes, it's expensive because the auditor has to be paid. Then it will require time for the auditor to understand the production process because he's not familiar with the company, because he doesn't know where the production hall is, he doesn't know where the machines are. It might give him, it was not around when the ACs were installed or when the new generator was brought in. So it will take him quite a while to get himself familiarized with all those steps. Then it will require support from internal person. And this is where the big thing comes in. When an external auditor comes in, there's always this jittery and uneasiness amongst people who probably are benefiting from the energy efficiency of the system, or they are benefiting from the waste. Okay, the man who buys the diesel and who doesn't report how much he buys diesel. Once you come in and you ask him how much diesel do you supply every month, he is less likely to give you a prompt response. If you're asking the man keeping the record of the energy consumption who goes to the AEDC or ECO to pay energy bills, or who already had a deal with the energy distribution company, he will be less likely. So this is another disadvantage of being an external auditor. So these are the two auditing categories. Okay. Then there are levels of auditing. Not every auditing is the same. We have basically, based on ISO 50002, we have 3 levels of auditing. We have level 1 auditing, we have level 2, we have level 3. Another name for level 1 auditing is what we call walkthrough energy audits. It's a walkthrough. Is a walkthrough energy audit. Then the second one is also called detailed energy audit. You either call it level 2 or you call it the detailed energy audit. Then the third level of energy auditing is now what we call the investment grade audits. So shortly, I'm going to give you the differences. I'm going to read it out. But let me just tell you this in a snapshot, how you can spot the differences between the different energy auditing. The walkthrough audit is the simplest. The walkthrough audit is the one you can do for free. The walkthrough audit, you don't need to measure anything, or just 1 or 2. The walkthrough audit, as the word implies, is a walkthrough. You walk through the company, you look at the AC, you recommend, You look at the lighting, you say, oh, change all of them to solar, change all of them to LED. Okay. You look at the refrigeration, you find out that there are leakages. You say, oh, this fridge is gone, take it out. You look at many production processes and you can make a walkthrough auditing using your visual inspection, using your level of knowledge and experience. But the level 2 audit is different. The level 2 audit is more detailed. In the level 2 audit, you need to take measurements. You need to use your ammeter. You go and take measurements. You need to use your light, your loss meter to measure the lighting. You need to use your what do you call it again? A lot of instruments. You need instrumentation for the level 2 auditing. You need to have records. You need, and then in the reporting, you need to do some level of costing. In your costing, you do 2 types of costing. You do low cost measures, medium cost measures, and high cost measures. So you can see that level 2 auditing is more detailed, is more professional. It takes more time, and of course, it takes more money. Then finally, you have the investment grade audit, which is the 3rd level of auditing, investment grade audits. Now, the investment grade audit is everything about level 2 plus more. So when you talk about investment grade audit, it's all the things you do in detailed energy auditing, you must do it in investment grade, plus 2 things more. You do 2 extra things. Those 2 extra things you need to do is you need to do some level of social impacts, environmental impacts. You consider it because, and then you do a high level financial analysis. So these are the 3 things that can differentiate a level 2 audit and level 3 audits. Level 3 audit is everything about level 2 plus these 3 things I mentioned. You must perform some high level or high impact financial analysis, like the net present value, internal rate of return, payback period. You need to indicate it because when we say investment grade audit, it means it's a bankable audit. It's something you can take to the bank. It's something you can take to the government, and then government will fund it. Government will provide money. It's something you need to take to tenders board, to management level, to say, look, we're going to borrow money. We're going to implement this. In 5 years' time, we're going to recoup that money. So the management can take it to the bank. I think Access Bank has such thing, and say, bank, give us money. So the bank will not accept a detailed audit. They will not accept a walkthrough audit, but they will accept investment grade audit because investment grade audit is the highest, is the highest professional level of audit you can ever get. So I'm going to leave it with us. I'm not going to read out everything that is here because we're going to have these materials. But these are basically what these 3 levels of auditings are. Okay, and let me say this for those who are joining us. This training is not going to transform you to an energy auditor automatically. You have to do the work yourself, but we're going to give you a head up. We're going to give you materials. We're going to give you all that you need to know. So now I've given you these 3 things you need to know. What you need to know in level 1, what you need to know in level 2, and what you need to know in level 3. So I'm going to leave you with that for you to now learn more about how do you now go about studying how to do MPV. How do you now go to do air quality reports? How do you now going to do social impact report assessment? Sorry. How are you going to do environmental impact assessment of the energy audit you want to do? Okay. Then for the level 2 audit, you are now going to know how do I do a low cost, medium cost, and high cost energy management system. And then you're going to learn how to write your reports. Even though I have promised to give us templates, whole lot of templates, but the work is going to be for you. So this training is going to tell you this is what you're going to do, but we're going to teach you how to write a report for crying out loud. Okay. Any questions so far? I must admit that I'm very fast, but forgive me. It's 3 hours, and I feel like downloading everything. Any question?
Some of us just joined. Good morning, sir.
Okay, some of us just joined. I'm on slide number 13 of 166, This is part one. So I'm going to review all I've said again from slide 1 to slide 13. Next week, I'm going to say more. Okay, let me take it to slide 20. Then we'll move. This is part 1, part 2. I think we still have a whole lot here. So for those who are joining us, the videos are recorded. I crave your indulgence to just be patient. These are the 3 levels of auditing. So the walkthrough audit, as I said, the steps you take is you establish your energy consumption in the organization. You estimate the scope of savings. How much can we save? You identify the most likely and the easiest area of attention. You identify the immediate low cost or improvement measures. As I said before, in the walkthrough audit, you're not going to perform economic analysis. You're not going to do any high level measurement. All you need to do is more of coming up with a low cost measure, and no cost. Okay, it mustn't involve money. You can just tell management, we're going to change all our bulbs, all our CFL bulbs to LEDs. We're going to change all our ACs, wall unit ACs to split units, and not just split units, but those that have high star ratings. We're going to learn to off our heater. I did audit for one of the hotels in Abuja, and guess what? They leave their heater in the kitchen on 24 hours in a day, and they don't have overhead tank. What they use is a run-through pump. And what it means is that every time a client opens the tap, the pump comes on. We're talking about the 2 kilowatt pump. So whenever there's a pressure drop in the system, the pump automatically comes on. And I was like, what the heck? So I recommended them to find a way and have an overhead storage tank for the water so that the water can flow through gravity. Okay. Then for the heater, we told them to start using hot plates or gas. Okay, instead of using electricity and putting the heater on. I mean, hot water. Anytime you need hot water is available, then you put the heater on. And this is a massive heater, by the way, about close to, I don't know, 2,000 liters or so. Okay, about that. 20 liters, sorry. Okay, so the walkthrough audit, as we said, is very simple. You just establish the most basic things that you need to do. So the 3 steps for the walkthrough audits, which is just the same with every other audit, is you conduct your site visit, understand the energy consumption, identify and evaluate low cost and low cost measures. Take note of that. Then identify more capital intensive measures needed. So you can identify things to do, but you're not going to make cost projections for them. Okay, so these are the activities you need to undertake. And then in your output, in your report output, you list all the energy improvement measures, including saving opportunities with less than 2 years payback period. You do a rough assessment of saving opportunities, of course, with a low payback period. Then you give them a summary table of measures they need to take. Then you just do an executive summary for the walkthrough energy audit. So all these, we can go through them. I'm not going to go through them. Then for the detailed audit, just like you have in energy audit, you conduct detailed site visits, but this time around, we focus on specific parts of the industrial site. You do a detailed study of the subsystem with larger sites. Then you do a comprehensive energy audit at site level with input from the organization.
This network is hanging. Oh.
The audio is off. We can't hear you again.
Okay. Sorry. The network took me out. Yeah, we're back. So so this is the detailed energy audit, which is the level 2 audit. Remember, level 2 audit. So the output of your auditing will now be for you to identify all energy saving opportunities to be quantified. Now, in the walkthrough audit, there was no quantification, but we said in our beginning that energy auditing involved 3 things: identification of energy saving opportunity, quantification, and then reporting. Please, if you forget anything, don't forget these 3 things. Identification, you need to know how to identify them by this training, by the knowledge, by your exposure, by your experience, by your expertise, by your study, by your research, and by your googling. You need to know them. Then you need to quantify them. You need skills. You need skills. You need Excel skills, basically. Excel. You need to know how to put them in table. You know how to compute the energy saving measures. This one is saving us 2 watts per day. In a month, it is 2 times 30, 60 watts in a month. Then the cost of energy is 15 naira. So that means in a month, it's going to be 30 times 50. So we are saving 1,500. You need to have that experience, that cost experience, which of course is beyond the scope of this training. Then the next thing, you need to do a detailed economic assessment vis-a-vis cost benefits for each proposed measure. It is not often that you go to a management auditing and you tell them you must buy this from Siemens, you must buy this thing, you must know. Give them option, give them alternatives. And then this is even where your expertise comes in. When you give alternatives, you provide economic analysis of those alternatives. You say, if you do this, you're going to save 20 naira, but it will cost you 15 naira. If you do that, you're going to get 15 naira, but it will cost you 100 naira. So you must have that knowledge and expertise to perform those economic analysis, which is what we're going to do in the last day of this training, so that when you present it, they will begin to see from a superior point of view. Then the next thing you do is you provide your summary table of all the measures, okay, with their payback period. Then your detailed energy audit must also have an executive summary. The place of executive summary in energy auditing cannot be emphasized. Let me say this. Most times when we do reports to management, they are not interested in reading our reports. They are too busy. So what they do is they just go through your report, go through the executive summary, and then they will collapse all that you've said. I think that's what most top CEOs do. They don't have time to read your reports because they are very busy. Or they can give it to somebody to read. But if you have an executive summary, believe me, they're most likely going to read it. So that's why you must include executive summary, and it must be professionally done in a language that is very simple, no use of high ambiguous terms. Just make it simple and stupid. And as I always say, remember to mention the numbers. They are interested in the numbers. This energy measure is going to cost us 2 million naira, but we're going to save 4 million. They want to hear that, and just give it to them. Okay. So these are the principles. These are what an energy auditor need to know. I don't need to read them. They are self-explanatory. Now, there's no place for detailed investment grade audits. Why? Because investment grade audit is just as good as the level 2 audits or the detailed audits. There's not much difference. The only difference is that issue of putting environmental and social impact. What are the environmental impact? What are the social impact? Because most times, these are the selling points for international organizations. They want to see what are the social impact? How does solar mini farm in this community affect the well-being, influences the poverty rate, and so on and so forth. And this expanse of land that you want to use to establish a mini grid, a solar farm, how does it affect the usage of that land for agricultural purposes? I remember many years ago when wind started in Germany, there were a lot of environmental and social issues associated with the implementation. For instance, wind turbines were killing birds, and people suddenly said, no, we don't want wind energy, they are killing our birds. When marine came in, the one they want to install turbines at the North Sea, that so they can provide the wind current can provide that energy to turn the turbines. People say, no, all our fishes are going to die. So you see that most times in implementing energy efficiency outcomes, you might have to consider the social and environmental impact. Some people may pay more attention, especially in the developed world. Environment is very important to them, and the social impact of those your proposals or those your alternatives are also important. Thank you, Excel. Identify, quantify, and report. Yes. Okay. So that is that. Remember, I'll be stopping at 11:30. Yes. So let me run ahead. So we have explained everything about the steps. Here we're just trying to further analyze them, the steps you need to take. So we say, as an energy auditor, there are 3 principles. You must be competent, and that is why you are in this training. You must have some level of confidentiality. When after doing your audit, you don't need to tell everybody on the street that those department or that department is consuming a lot of energy. You don't even need to go and report to the Megad that he's consuming diesel. When he says he buys 20 liters of diesel, it's only 10 liters that you see. You don't need to do that. And then you have to be objective. So most times, management, after auditing, you must report to the boss and allow the boss to scale it down. Now, the principle also that applies consistency with the agreed scope. You must be consistent and with the scope, the boundary, and the energy objective. You have to define the objective. Why are you doing the energy auditing? We want to save energy. We want to pay less energy bills. We want to use the money we save for workers' welfare. So you must define it. And you must make sure you don't go beyond that scope. You don't go start to indict somebody. You don't go start making recommendation who to sack, or even giving the impression that your report or your energy auditing is going to lead to somebody's sacking. I mean, you don't have to go that far. Okay. The measurement and observation is appropriate to energy use and consumption. So there are some measurements you don't need to do. So you must do the measurements that are necessary. For instance, if it's not a production hall, I don't need to go and start measuring the light luminosity. Oh, I want to see this light says, the manufacturer says 80 watts. I want to make sure it's 80 watts. I mean, there are some measurements that are not necessary. Absolutely not necessary. So you need to stick to what needs to get you those energy saving measures. Then collected energy performance data must be representative. If you're collecting sample data, it must be representative. Let's take, for instance, you are giving me an energy bill, how much you are paying your energy bill for the whole year. Okay. If I'm taking it at the end of the month, I must be consistent. Okay. I can decide to take one from every quarter, during Harmattan, during cold season, during winter, during spring. I must make sure I take it out, because if, for instance, if it's in Germany or in Europe, the energy consumption of everybody goes up during winter. We know that, because then you need to burn gas or whatever to get heat. Okay, and your heater comes up all the time. So, and then some processes will be optimized so that you won't have an issue with snow. And I mean, that is that. Then the next thing is the process of collecting your data must be transparent. It must be traceable. It must be something that everybody can relate with, so that you can defend your data. So you must say, I'm using ammeter, I'm using the NEPA, the report from the energy consumption for 2018. So it must be well. Okay. Then
okay, that's okay.
The next thing.
Please, somebody is talking.
Yeah, I've muted him. Okay. So we cannot read this and understand further, please. Anything we need to read and understand, I don't need to go through it. So
just
those who didn't come on time.
Still recording. Are you still recording?
I am sure I am. Yes. Yes, sir.
Yes,
Okay.
it is still being recorded.
Yes.
Okay.
So those who didn't come on time, let me just quickly do this. Okay. When we started, we said, we defined what energy auditing is. We said saving opportunities, and for you to save any opportunities, you need to identify them, you need to quantify them, and then you need to report them. We now said there are two standards, the EN standard and the ISO standard. But we quickly pointed out that these two standards are virtually the same if you understand them. And I also mentioned things about this code and standard, that those days, I remember if Germans say their standard is 1.5, the French will say 1.49. So they are just the same thing. For the EN standard, you do a preliminary contact, you do a startup meeting, you collect data, you do your field work, you analyze. If your analysis is not giving you what you want, you head back to collect more data or take more readings. Okay, and then you report your findings, and then you conclude with the final meeting. ISO 50002 says, okay, let's improve it, which is the latest anyway. I say, number one, you must first start with your energy audit planning. You need to sit down and plan. But that planning can also be done in conjunction with the management. Okay, somebody in the top management, so that they can get the buy-in and of course pay you your money. And then after that, you move to the opening meeting. The opening meeting can also coincide with data collection. You can also use the opportunity to collect data. Okay, as you mean, it's a walkthrough audit. You can collect verbal data. They can tell you what they are mean, because walkthrough audit, as we said, this doesn't have much a headache in quotes. Then after the openings, you do your measurements. You go and take measurements. Okay. After your measurements, you conduct site visits. So this is where site visit now comes in. So you can move back and forth, site visit, measurements. Then you go back to analysis. And during analysis, you can also go back and take more measurements, or adjust your measurements, or take more readings. Then after that, you now do your reporting, which in this case is now called energy audit reporting. But report is report. Then you now do your final meeting or closing meetings, which we said can take any format. Okay, so we now jump back to where we are. We can't just go back again. So here, so measurements. Okay, so this is how you do your measurements. The standard does not specify the walkthrough principle. However, all equipment should be visited. So under walkthrough audit, for your field work, this is what the EN 12647 says. Okay. And then reporting, an outline of report is provided, yet the content is not specified or described. So this is more like some of the observations that have been made under the scope of the EN standard. Then we said planning, energy planning, audit planning. What is audit planning? Well, this is how you do the audit planning. You set up the objective, the criteria, and the scope of work. You set your boundary for your units. You know where to install, which building should be examined. So these are like the planning process, which is the first step. The first step in ISO. The first step in ISO says planning. So I'll leave it with us to read more about that. Still on planning, what is the role of the energy auditor in the planning? The energy auditor shall inform the organization after of any special facility or equipment required to create the energy audit required to enable the energy to be carried. So after your energy planning, you can inform management what and what you need. Maybe you might ask them to install meter, a check meter, for instance. This is something that is common. If you don't trust what the discos are giving you, or the position of the meter is not known, is not accessible, you can install a check meter. So these are things you recommend to management. Say, look, we need to do this, we need to install this, we need so that we can do this thing. Or you need to call one or two people in order to order, tell them to cooperate. It can also be. Or you can even request for management to assign some staff who you feel will help your work. So this is what you do in it. He said commercial or other interests which could be influence his or her conclusions or recommendation. So an auditor should be able to discuss money at this stage, or discuss how it's going to be remunerated. Then you should be able to also discuss other conflict of interest if there are areas, so that, let's say I'm a solar panel distributor and I suddenly go to do auditing and I'm telling them to buy a particular brand of solar panel. I mean, that is conflict of interest. So I need to explain to them that, look, I am a solar distributor in Nigeria, but you mustn't buy from me. Or let my recommendation not be that I'm trying to promote my wares, sort of. Now, moving to data collections, what do you need to do? There are areas you collect data as an auditor. You can collect data from the raw materials, okay? And what data do you collect there? You can collect production statistics, both for finished goods and for unfinished goods. You can collect data for processed material. Why do you need this data, if I may ask? Because garbage in is garbage out. I mean, input is equal to output based on Langerian principle. If we are producing 20 cars in a day and we are consuming 50 kilowatts, and tomorrow we started producing 40 cars, you don't expect the energy to remain the same. So you see that in collecting data, you have to also collect your raw material data. Raw material should be the first point of your data collection processes. Okay. Then you can also collect data of byproducts and waste disposal. Okay. It also has a way of keeping you to tab. The waste products can also be a correlation or a reflection of your energy consumption pattern. You can relate the two. You can, because your byproducts can also give you an idea of your waste products. Sorry, your waste products can also give you an idea of your input. So vice versa. Then the other thing is effluent analysis of chemical composition. So assuming you're going to audit a treatment plant, the effluent quality can influence the energy consumption that have gone into the system. Yes. So these are just an idea to give you, so you can expand the scope to know how material and product data can guide you in your energy analysis. The next point of data collection is the energy consumption, which can be in form of your utility bills, your consumption reports, your data from submeters, your data from water and suppliers and other forms of energy. Then your data can also come from the process, the flow rates. You know, the more I mean, these things are can be correlated. Okay, the more energy steam you produce, the more the power rating of the boiler. Okay, the more you reduce the temperature of your air conditioner, the more it consumes energy. People don't know about this, but that's true. That's true. So while you are busy putting your AC in 18 degrees or 16 degrees, just make sure that you are consuming more energy. Okay, and when Engineer Chima comes on board, you're going to see that you can save like 10% of energy by reducing your energy, your temperature by 2 degrees. Yes. So those of you that enjoy 16-degree temperature, you might consider putting it at 22. Okay. And let me also say this. One of the things that this training is going to do for you is that it's going to add value to your own life too. Because after this training, believe me, you are going to perform a walkthrough audit in your own home. I have done that, and some of us have done it unconsciously. But this training might also prompt you to take a second look on how you are consuming energy and then make adjustments and save some few scarce naira or scarce dollar Okay, so these are other things you can do. You have to verify the source of data. If energy breakdown are from metering or calculated, you check time period and all this and all that. So in your startup meetings, there are some things you do. I've mentioned some of them, so I might not go through all of them. He said, number one, he said, the energy auditor shall request the organization to identify a person to liaise with the energy auditor. This is very important. Normally, the facility manager comes into mind when you go to do auditing, whether it's energy auditing, financial auditing, project auditing. See, find a way and identify an insider. Find a way and identify somebody within the organization that will be of value to you. And then have a way of incorporating the person and have a way of motivating that person. That person can go a long way in helping you to do a good job. He said, inform affected personnel or other relevant parties. You don't need to bump into people. Oh, I'm the auditor. I'm coming to change your energy consumption. And then suddenly people will be like, who is this? So you must make sure that the senior management introduces you to the people, tell them what you've come to do, and tell them that you're not here to hurt anybody. This is very important. It's very, very important. Then you also need to ensure the cooperated of the affected parties. See, even the gate man at the gate, you need to cooperate with him for you to be a good auditor. The man purchasing energy, you need to cooperate with him. The man, the lady in the kitchen consuming heater, you need to speak with her and say, look, you don't need to put this thing on all the time. Or before you recommend that they change her heater, let her know why you're changing it. Let it not be that it's an indictment on her and many other things. Okay, the audit steps for the field work. The purpose of the field work is to familiarize with sites and site procedures, obtain drawings, plans, and identify the energy cost centers. Okay, ideally, it's advisable that the site is fully operational when you go. Then one note of thing is this: you might not have to take pictures. Sometimes it's a controversial thing. You might not have to take, if they say don't take pictures, please don't take pictures, because people have their confidentiality, people have their privacy. So just take note that as an engineer, you can snap the nameplates of the equipment, but to snap the whole processes, to do video of the workers, I mean, these were days of social media. We don't know where that thing is going to go. And suddenly somebody takes it and then flies on social media and say, oh, company A, company B, this is what their boiler looks like. This is the way they treat their workers. So you have to be careful with pictures. More on the field work. You need to arrange for them to give you access to the plant site. You need to have some level of non-disclosure agreement so that you don't go and start disclosing their secrets. Okay, you need to have a proposed visit time and make schedule, and then so on and so forth. So there are a whole lot of things you need to take steps. So I'm going to leave it with us. We go through them and then know what we ought to do at the fieldwork level. Okay, so still on fieldwork, you have to do your inspection, evaluate the energy use, and many other things. You can read all this. You can read all this. So in the analysis, one thing I want to point out in the analysis is number 2. It says use transparent and technically appropriate calculation method. Don't go and start showing off. No need for that. Just use simple Excel, use simple net present value. Investment is this, payback period is this, discount rate is this, interest rate, very simple, so that everybody will be on the same page with you. Also document the method used, and if there's any assumption you made, there's always an assumption to be made. Then subject the result of analysis to appropriate quality and validity check. If you have a second party, a partner, you can sit down and make sure that some of these things are well articulated. He said, consider any regulatory or other constraints of the opportunities for improving energy performance. So the energy auditor shall identify energy performance improvement opportunity based on data analysis and their own expertise, evaluate the design and configuration option to address the system, the age, condition, operation, and level of maintenance. So in you identify the energy, performance, and improvement opportunities, you must be practical with it. So I will leave this with us. We can read all this, we'll understand more and more and more. So from what we've said so far, for the WTA, you have to focus on the no or low cost measure. You have to base your recommendation on experience. You need to give them a typical energy saving measures, which I have mentioned. Then you need to exemplify if data is missing. You have to identify. Then you need to talk about the overall investment. Then you can do a simple payback, which is optional. Then you can now highlight the possibility of doing a detailed energy audit. So one of the reasons why we do walkthrough audits is for you to have a basis to recommend a more detailed energy audit. And that is where we have a lot of work. So the reporting, he said before the closing meeting, the reports on the energy audit shall be provided to the organization. Closing meeting should be attended by the same staff as the startup meeting. At the closing meeting, the energy auditor shall present the value of the energy auditing in a way that facilitates decision making by the organization. Be able to explain the results and address questions. If applicable, identify items requiring further analysis or follow-up by the auditor. So if there are things you need to do further, things that are not finished, you can also recommend them. So reporting. Purpose of the report is to present the findings and recommendation of the energy auditing, as well as to pose a tool for decision makers regarding the implementation of energy efficiency or renewable energy investments. Thus, the report must contain all necessary information with agreed boundaries of the audit. Present information and result of the analysis on a simple and comprehensive way. Visualizing results where possible. You can give them a visual understanding of your report, of your result. Then keep in mind that non-engineers may read your report. So these are some of the steps you need to take in doing your energy audit report, which is the final things that you need to do. So that is the end of the class. Next week, we're going to continue. We still have so much to offer you today. So I have structured this to be part 1 and part 2. Okay, so we are end of part 1. I'll be sending this slide shortly, and my colleague Engineer Chima is going to take us up from 11:30 to 12:30. We'll be leaving the class by 12:30. 12:30 will be for us to ask questions, and then we now do the other things, introduce ourselves and interact. So this is where I'm going to end it. I'm not going to talk more about measurement and instrumentation. Hopefully by next Saturday, I will do that. So this is end of part 1 of this class. And for next week, I'll also get another expert that will share this measurement and instrumentation, hopefully. So, any question on this section? Engineer Chima, are you ready?
Hi, Engineer, thank you very much. I'm here.
I thought you said
ready.
it should be part 2 before questions will start coming.
Okay. Oh, how do we do it? This measurement and instrumentation will be part 2 next week, because I have only 1 hour. I have consumed my 1 hour or even more. Engineer Chima have to take his 1 hour. Remember our program, sir. Okay. So I know we are eager and we have a lot to learn, but let me say that what we can't do, we're going to have the videos. But for now, let's have a general overview. And as I said, let us know what we do as energy. Yes.
Let me just ask you something.
Any question on my section in 5 minutes? Chima, give us 5 minutes. You come online.
Yes, let me just ask you one basic one, if you don't mind, sir.
Go ahead, sir.
Now, I know that in the profession, we have scale of fees, right?
Yes, sir.
And during this your presentation, you dived into your remuneration.
Yes.
As an energy auditor, rendering
Mm-hmm.
service.
Mm-hmm.
Now, this your baseline.
Mm-hmm.
Is it that you just do it by hindsight, or maybe there is based on the normal fees that we know?
Okay, sir. Thank you. I think
for every other, to your clients.
okay. Okay, thank you. Because of time. Actually, when I say baseline, I'm talking about energy baseline. I'm not talking about your remuneration. When I say energy baseline, what I mean to say is that before you start your energy auditor, you need to do your load assessments and establish a baseline to say we are consuming 2,400 kilowatts hour every month. And this cost us 2.1 million every month, or for August, or for September, or for September, or per year, depending on your scale or your time scale. That is actually what I was referring to. But then, based on your question, the energy sector is an emerging sector. But for now, I think the ideal thing to use is to use 1 hour that we normally use in our engineering thing. How many hours is it going to take you to do this auditing? And how much is your fee per hour? For me, that's the best thing. If this job is going to take me 2 weeks of 8 hours per day. So that means that would be 10 days, 10 working days, which is 2 weeks, 10 working days. So that means it's going to take me 8 times 10, that's 80 hours. So this job is 80 hours. And then what is the rate for an engineer of my skill, of my level per hour? You multiply it, and that will be what your charge will be. I think that's for now. I'm not an expert in that, but if there's somebody that have a different perspective, you are welcome to tell us in just 1 minute.
No, in all honesty, you've hit the nail on the head. 1 hour will be just the best thing to do.
Yeah.
Thank you very much, sir.
Thank you, sir. Appreciate it. What's the name, sir?
Engineer Daniel, Principal Partner, Dean and Partners.
Okay, you're welcome, sir. Thank you.
Thank you very much for your presentation.
Thank you.
I would have asked more questions, but because of time, I don't know.
Okay, okay, we're gonna have a final. So put it down in the chat box. Then from our program, you can see our program. 12:45 to 1 p.m. We're going to have feedback, question, answer, comments, sharing of links and resources. So I'll brave indulgence to maybe with that. What Engineer Chima has to say is also going to be in 2 parts. Can't finish it in 1 hour, but I know Engineer Chima is going to speed up. While I make the materials available, I've made the 2 materials available, but when I close this one, I'll send it again to everybody on the chat box and share the link via cloud. Okay, before we welcome Engineer Chima, I know the chairman of the Maitama branch, which are the partners to this training, he's around. He's been coming on and off, maybe it's internet problem. So my chairman, Engineer Digbo Mogabaji, I don't know if you want to say something now or you want to leave it at the end. Technical Secretary, Engineer Chima, can you coordinate with the chairman?
He's saying that he can't hear your voice, so probably the network on his side.
Yes, I've been adding and removing him steadily. I think he's been coming and off, sorry, not me removing him. Maybe he has an issue. Okay, chairman is saying something. Okay, chairman, you have to log out and log in again. Log out and log in again. You did not log in with your audio.
I don't know why some of us are having that issue. You remember at first when you were trying to introduce me to the class, I was in the class, but I wasn't hearing anything. I have to keep logging up and then logging in until I have to change the system if I'm able to hear what you're saying.
90% of the time is always the network.
Yeah,
always
it's the network.
Always.
As we speak now, I'm using Airtel. I just switched from MTN.
It's the network. So it's not really a big deal. If you have a very good network, it will always take you straight. It will bring you in, then you now have the option of either taking the video or the audio.
Okay, any other question? Microsoft Teams is a better platform for training, but people are not too used to. People just know Zoom more than it. But that's a different thing anyway. Engineer Chima, while we're waiting for chairman, can you kindly introduce yourself and let's hit the ground running?
Thank you very much, Engineer Uche, for that fantastic presentation. You've really laid the background, and there's no better way to have done this. So thank you very much. Good morning, engineers in the house. I welcome you all to the second part of this training. Engineer Uche, I don't know if I'm allowed to share my screen now.
Okay, let me give you.
Please give me permission.
Yeah, let me give you authority. Please, if you have any question in the course of this training, don't hesitate to put it in the chat box. I'll be on standby to answer your questions, share the materials. Now that I'm free to move out to do that, Chima takes the lecture, so we are good to go. Chima, you can share your screen now. For those asking for group, we already have a WhatsApp group that have been existing. So I'll just share the link. You can join it for more mentorship and more burden. It's already there. Chima, go on.
Okay, thank you, Engineer Uche. Can you please confirm if my screen is visible now?
Yes.
Okay, thank you very much. So once again, I welcome you all to this to the second part of this training. My name is Engineer Chima Moneke. I'm a certified energy auditor. Engineer Uche and I has been running a couple of trainings, including this very one that we are delivering today. So I'm glad to be here to share and co-learn with you guys, my colleagues.
Chima, can you raise your voice or maybe move close to the system, please? Okay,
sorry about that. Am I audible enough now? Is it better now?
Yeah, it's better.
Okay. Thank you for that.
And in case you are using earpiece, from the experience of the former presenter, maybe you can do away with your earpiece.
Okay. But it's clear now, right?
It's good.
Okay. That's so. But in case along the presentation, at any point my voice begins to fade or it begins to crack, please. Sometimes the speaker wouldn't know unless the listeners call his attention to that. So if at any point my voice begins to fade or begins to crack, please let me know. So without wasting much time, I will just have to dive into the presentation because we have a lot that we need to cover in 1 hour or less because we've already spent some time into this. So I guess I don't need to read through all this again. Engineer Uche must have talked about the objective of the training. And like he said in his introduction that we're all here to co-learn, to learn from one another. For the fact that I'm leading this session does not mean that I know it or that I'm more expert than every other person. But I just like I said, also to point us to the things that we should know if we have to become a certified energy auditor, meaning that we can become certified to conduct energy audits anywhere around the world. That's what it means. So it's an international certification. So there's a special curriculum that we should adhere to. So that's what we're just going to be directing you to in the course of this training. So first, I usually like to start by trying to remind us the concept of sustainable energy, what sustainable energy is all about, because it has become a buzzword in today's world. When people talk about climate change, they talk about green energy, clean energy, energy sustainability. Just to refresh our mind to what sustainable energy is all about. So sustainable energy means two things, basically. The first one is energy efficiency, and then the second one is renewable energy. They are two different things, but they are related. They are like a twin brothers or a twin sisters. Okay, so to achieve sustainable energy, you need to have the component of these two combined before you can say, okay, that you've been able to achieve sustainable energy. And that's the reason why we're even talking about energy. And for you to achieve sustainable energy in whatever form, whether as your house, as residential, industries, or commercial, the first point, of course, is to conduct an energy audit. You need to first of all understand energy flow into the house and out of the house. What energy being used, to perform in the house? If you understand all of that, you can now begin to identify or begin to spot areas where improvements are needed or where energies are not being used optimally. So, and essentially, that speaks to energy efficiency. Okay, for you to implement energy efficiency, you need to conduct an energy audit. Then you have to do an energy efficiency measures. Okay, so back to the concept of energy sustainability. First thing I say, you have to implement energy efficiency measures. First of all, you have to identify the areas where energies are not being used optimally, and then you have to take measures to eliminate them or optimize their use. And that is what energy efficiency is all about. Engineering has given us the definition of energy efficiency, so I'm not going to go into all of that again. Then the second part is the greener energy, where you have to now provide your required energy. You have to now provide it from a source that is renewable, and that's why we talk about renewable energy sources. As we progress along the training, I will make it more clear why the boost for renewable energy is top-notch, or is the main thing globally now. So these are the two things that has to make sustainable energy sustainability complete. So let's start with the with energy. So what is energy? I know most of us here are engineers, if not every one of us are engineers. And one of the objectives of this session is to bring every one of us to speed. A lot of us have left school so many years ago, and we may not have been practicing in the space or in the energy space. So this is just to bring every one of us to speed. And I crave your indulgence. For those of us that has already become too familiar with the things I'm going to be talking about, I crave your indulgence to please just be patient. This is just to familiarize us with the concept of, or rather the basis of what we're going to be discussing from today going forward. Okay. So what is energy? Energy, the word energy has its origin from the Greek energia, which means active, drive, rigor. I don't want to read all through this because we will have this slide to study on our own. So I'll just I will move as fast as I can to talk about the important things. So energy is the capacity to perform work or heating or cooling. So an energy is one of the most important concepts of natural science. Let me not just read all this and then go through the important things. So we have different forms of energy. Okay. So we have mechanical energy, we have thermal energy, we have electromagnetic energy, we have electrical energy, we have chemical energy, we have nuclear energy. So it's important that we understand these forms of energy. And why it is important, you will be solving some problem and then you will hear something like kilowatt electrical. Of course, everybody knows that kilowatts in most cases means electrical, but you also hear something like kilowatt mechanical. Then some of us will get confused. You will also hear something like kilowatt thermal. You get confused. So it's important that we understand the different forms in which energy exists, and we should also understand that kilowatt is just a unit of energy. So when we say kilowatt, the question should be, what kind of kilowatt are we talking about? Is it electrical energy? Is it mechanical energy? Is it thermal energy? So it's important, and that's why I want to make us understand these different forms of energy, or different forms in which energy exists. So you have mechanical, you have thermal, you have electromagnetic, you have electrical, you have chemical, you have nuclear. And if you go further, you see examples of these forms of energy. So there's this general acceptable law. Does someone has a question? I'm hearing somebody's voice.
Just mute them.
Uche, please just mute everyone, please, so that we don't get interrupted.
Continue, please.
Okay. So there's this generally accepted principle of energy conservation. Okay, so I'm just going to remind us of that principle, and then I will try and relate it with how it affects. In fact, I'm going to use that principle to define what climate change is today. So most of our energy sources, if not all, because I don't know, as an engineer, as a scientist, I don't know if we can trace the sources of all energy. Thank you, Genoche, for motivating everyone. Okay, so I don't know if we can trace all the sources of energy. I mean, all the sources of energy. I don't know if we can trace them to a single source. Okay, but if we can trace it to a single source, then that has to be the sun. Okay, so the assumption here that all the sources of energy that we use in the world comes from the sun. And so from the sun, how does it now begin to transform up until it gets to different forms that we use them today? Okay, so we all understand the concept of photosynthesis, whereby the plant or living, the green plant converts heat, to carbohydrate and the food that we eat through the process called photosynthesis. And we all feed from this plant, and both human beings and animals will feed from these plants, to derive our energy. So at the end of our life, after we've lived 100 and several years, and then at the end of our life, whether the plants, the animal, or the human beings, at the end of our lifetime, we die, and then we would then undergo through a process of decomposition. Through the process of decomposition, we now form what we know today as crude oil, or gas, or hydrocarbons, or fossil fuel, as generally we call them. So, and this is a very long process. This is a process that takes millions of years. You know, it takes millions of years for living organisms to transform or to decompose and form crude oil. And that's why it's a problem today, because of that long time it takes to form the crude oil. It is not sustainable. The rate at which we are using the crude oil is far greater than the rate at which crude oil are being formed. But that is not even the problem. Now, the thing is this, because we don't have the right technology to use energy directly from the sun in form of electrical energy, in form of mechanical energy or chemical energy, we find it very more convenient to extract crude oil from beneath the earth, okay, to crude oil exploration. Okay, by nature, God has designed that the sun comes down to the earth, it provides all the energy that we need to survive, and then these energies are being sequestrated, they're being stored underneath the earth. Okay. But for the fact that we don't know how to get our desired kind of energy directly from the sun, we now explore this crude oil and we now use them to power our economic activities. Okay, now here is the problem. Because the sun is already providing sufficient energy for us to use on Earth, and then we now go ahead and then extract further crude oil from the ground, and then we use this crude oil to power our economic activities. Now, the end point of most of this energy, the crude oil that we extract from the Earth, the end point for most of them is heat. So the heat that we're extracting from the earth, from beneath the earth, combined with the energy from the sun, causes the temperature of the earth to rise beyond. If we continue exploring crude oil, the temperature will continue to rise beyond a limit that will become unfavorable to human beings, or become a threat to the survival of human beings. And that is what we know as global warming. This is how the concept of global warming came about. And the world government wants to put an end to this. And that is why researchers have to go into the lab and then begin to find how we can get, or how we can convert the energy from the sun directly into electricity to power our economic activity. So this is the reason why researchers have to now invent renewable energy. Okay, so now with this concept, I've been able to explain to you what the law of energy conservation. I've also been able to explain to you the reason why global warming is a threat to the entire world, and also the reason why we have to come up with renewable energy concept. So this is just the word explanation of what I've explained. So energy does not remain in the same form always. To cause change, energy itself changes from one form to another. So during changes, energy is always conserved. That is, it is not created anew or destroyed. This is known as the law of energy conservation. We already know this. So now let's talk about energy and power. These are two different concepts. They are related, but they are also two different concepts. And most times we mistake these two for each other. Okay. So it's important that we differentiate between energy and we differentiate between power. They are two different things, like I said. Energy and power are closely related, but are not the same physical quantity. Energy is the ability to cause change. Power is the rate energy is moved or being used. So here I will try to differentiate it a little bit more. So energy is the capacity to do work. Capacity to do work. Why power is the rate of doing that work. So if you buy your battery, that you want to use to power your torch, you're buying those batteries because it has capacity. So it has energy stored in them. It has capacity to do work. It has capacity to do work. It has capacity to light your bulb. So you buy those batteries, but while you're using those batteries, the rate at which you're using those batteries is power. So they're two different. So energy in the scientific definition is force times distance. So if I apply a force on a particular object and that object did not move, I have not dissipated energy. I have only dissipated energy when that object moves. That is when I have dissipated energy. So it is force times distance, and the unit of energy is joule. And the definition of joule is Newton times meter. All this sounds very, very scientific, but not to worry. We'll get used to it. They are not to be neglected, because by the time you begin to do energy calculations, you're going to be seeing they will give you energy in the form of joules or kilojoules, and you might be required to convert them into kilowatts. So it's important you also understand this. I'm just saying all of this to lay the foundation or to lay the basis of, by the time we go into industrial energy auditing, you begin to see the in real-time applications of all of this. So power is equal to energy over time, energy divided by time, okay? And the unit of power is watts, okay? So if we make energy the subject of the formula, remember I said that power is equal to energy times time. So if we make energy the subject of the formula, we will have energy is equal to power times time. And that's why when they bring your electricity bill, you're going to see your unit, your energy consumption in kilowatt hour. Kilowatts means power. The hour means time, and that is energy. Okay, so energy is kilowatt hour, while power is watt or kilowatts. These are the two different things about their unit. So I'm not going to spend more time on this unit. I've already spoken about the unit of energy and power. So here is a little exercise. I don't know if we want to try this. I usually encourage participants to try this. That helps me to know that everybody is following, or to know if there are areas I will also need to make more emphasis on. Can we do this? If we have our calculator, it's a simple calculation. Can we just try this and then provide our answers before I go ahead? I will give 30 seconds for this, please. If you have your answer, you can unmute yourself and speak, or you put it in the chat box.
You can just put your answer on the chat box.
30 seconds, please. If nobody gets this correct, we'll just proceed. I believe we are engineers and we should be able to do this. So the question is, what is the cost of 5 kilowatts continuous operation in 1 year? So this is the basic calculation that as an energy auditor, you should know, and that's why it's important. There are more complex calculations. Believe me, there are more complex calculations. Energy auditing is all about mathematics and the science behind it. Okay, someone has posted an answer. Is your answer in dollars or naira? 4380 in dollars. Thank you. Okay, so without wasting much time, let's see. Let's see if he gets it correct. So, and he's correct. So here is the answer. For any of you, if any of you get something that is different, please, you might just want to speak. So let us know what you did and then correct you. But this here is the solution. Here is the answer. First of all, you need to calculate. Of course, the calculation for the total hours in a year has been done for you here. So, and they say this is 5 kilowatts that is continuously used. So you multiply this 5 kilowatts by these hours in a year to give you the energy. What we are giving is power. Please, we should mute everyone at this point. So what we are giving is the power. So we have to first of all calculate what energy this facility consumed for the year, and the hours is 8,760. So if we multiply these two, we are going to get 43,800 kilowatt hour in 1 year. And we are told that the unit of that energy is 0.1 USD or 10 cents. Okay. So if we multiply this unit of energy by 10 cents, we are going to get 4,380 USD per year. So let's talk about renewable energy sources. So like I did when I was doing the introduction about how we are now transitioning from the energy source from fossil fuel to the renewable energy sources, which is now the whole bit about energy sustainability, climate change, and all of that. So let us look at renewable energy and non-renewable energy. So for the renewable energy, we have the solar radiation energy from the sun, we have hydro, we have wind, we have ocean-related energy, such as wave, tidal, thermal gradient, salinity gradient, and the rest of them. So we have biomass. Biomass are the maybe byproduct of plants, crops, wood, forest residue, waste, and the rest of them. We have biogas. We have geothermal. All these are classified as renewable energy, meaning that they cannot be exhausted. No matter how you use them, they are easily replaceable. So we also have non-renewable energy sources, such as the chemical energy, like the fossil fuel that we talked about, which is what we're trying to move away from. You have the coal, you have the oil and gas, and they will also have the nuclear energy, the uranium, and the rest of them. So let us talk about utilization of energy. So before we talk about, we'll go into the full details of utilization of energy. Let us look at the indicators. What are the variables? What are the measures through which we can measure energy performance? So more like, how do we measure energy efficiency? If we have two situations to compare, how do we know which of the system is performing better than others? So that's where we'll now talk about the coefficient of efficiency. Okay, so coefficient of efficiency is giving us the useful energy plus the losses. So if you're looking at a system, you're giving a particular system to audit, it's important that you know the energy that is going into that system. Then it is also important that you identify the useful energy in that system, and then you also identify the losses. So if you identify these three things, then you can say that you have now understood, you've done more like what we call the energy balance equation. So this is an energy balance equation. Energy in is equal to useful energy plus energy losses. So the ratio of useful energy and total energy input in a process is called coefficient of efficiency of energy transformation, or transformation efficiency. And this is how it is measured. Useful energy in all over energy input, not all the energy that goes into the system that becomes useful. So this is how we represent it. The useful energy that you use in a system is equal to energy in minus the losses all over energy in. So, and of course, the system boundaries has to be defined. The scope has to be defined. Okay. So if we understand what I have just said now, let us do this little exercise. If a liter of diesel contains 10.7 kilowatt hour of electricity, of course, we buy diesel not because we like diesel. We buy diesel because of the energy content of the diesel. Okay, and that's what we care about. So if that 1 liter of diesel contains 10.7 kilowatt hour of electricity, and the generator produces 3.5 kilowatt hour of electricity per liter consumed, calculate the coefficient of efficiency. Okay, the generator that we have in our homes today is just an energy converter. It converts chemical energy from the diesel to an electrical energy. Okay, so in the process of that conversion, a lot of energy is lost, a lot of energy is wasted. Okay, so in this example, I want you to just run a little calculation and tell me the coefficient of performance of this system that I've just presented to you here. This is a very simple one. Let me see if you have the answer, put it up, please. Okay, I've seen about 30%. Why about? Just give me the figure. I mean, it's a straightforward calculation. Someone said about 30%. Do I have another response? Let me not waste time on this. 32.7 from Noah, Engineer Noah. Okay. Thank you very much for your response. So how to do this actually is a simple division. Your energy input, your useful energy is 3.5. That's the useful energy that actually comes out. 3.5, you divide it by the energy input, which is 10.7. And then you have 32.7. Yes. So Engineer Noah, you got it correct. So I believe we understand this. So let's also talk about energy indicators. Energy indicators. So there are several indicators when you're talking about energy system, and one of them is specific energy consumption. Specific energy consumption, just as the name implies, it is specific. So if I come to an industry and you're producing, maybe if I come to Dangote and Dangote is producing macaroni and is producing spaghetti and is producing what else? What other pasta? But let me say macaroni and spaghetti. If I'm talking about specific energy consumption, I want to know how much energy he uses to produce 1 kilogram of macaroni. Specific to macaroni. I want to know how many energy he used to produce 1 kilogram of spaghetti. That is what specific energy consumption is. So the ratio of energy consumption to corresponding production quantity, that is specific energy consumption. So it could be something like maybe 2 kilowatt hour per kilogram of macaroni. Okay, so it becomes a specific energy consumption. If by next week he starts spending 3 kilowatt hour per kilogram of macaroni, there's something is wrong. He may not be competitive in the market, and that's why it's important to measure your specific energy consumption. I hope you understand now the concept of specific energy consumption. So there's another one we're going to talk about. So I'm going to talk about energy intensity. Now, these are two related concepts, but energy intensity is a little bit different from specific energy consumption. So if I'm still talking about Dangote and I want to know his energy intensity, I may not be talking about macaroni this time. I may not be talking about spaghetti this time. I can group macaroni and spaghetti and say, okay, for all the product that Dangote produces, all the production that Dangote does, he spent maybe 10 kilowatt hour per kilogram. That's energy intensity. All the production of that plant is 10 kilowatt hour per unit kilogram of all the products combined. So that is energy intensity. So the quantity of energy required per unit output or activity. Example is the GDP, the Nigerian GDP. How much energy do we use to generate one GDP? Okay, so that using less energy to achieve the output reduces the intensity. So when we are looking at this at a global level, you want to compare the energy intensity of different countries. If you compare the energy intensity of Nigeria to some of our peer countries like Indonesia, Malaysia, Pakistan, you will find out that Nigeria is using more energy per unit GDP than this country that I've spoken about. And that is why our economy is not competitive. If you produce something in Nigeria economy, please mute everyone again. Please, you don't have to unmute yourself unless you need to ask a question, please. So let us not distract the class. Okay, I was talking about the energy intensity. When you compare the energy intensity of Nigeria to other peer countries, I'm not even talking about the US and Europe this time. I'm talking about peer countries like Malaysia, Indonesia, maybe Pakistan and some other economy that you can compare with Nigeria. You'll find out that we use, in fact, according to the research done by GIZ, they say that we spend about 40% more energy per unit GDP in Nigeria, meaning that we are spending a lot of energy to generate a unit GDP. So that's something to bother us. That's something to worry everyone. And that's why we need to improve on our energy efficiency in our industries, in our homes, in our businesses. So here is another exercise. I like showing up these exercises just to make sure that we understand this in terms of numbers. Okay. So this is an exercise. If a manufacturing company consumes 1,500 kilowatt hour, now this is energy of electricity to produce 100 kilogram of wheat, what is the specific energy consumption of the wheat? Can anyone just throw up the answer? These are simple calculations. And if at this point anyone is not getting it correct, then we need to find a way to carry everybody along, because these ones are very basic. By the time we get into some other complex calculation, then it will be something else. So at this point, I want everybody to be carried on. So I've seen 15. Who has 1.5? How did you get 1.5? So it's just a simple basic calculation. You divide 1,500 kilowatt, that's the energy, by the production, which is 100 kilogram. So let's just proceed. So let's just talk about electrical energy. So basic electricity, okay? So we'll talk about electricity. What always comes to mind is, maybe for those of us who understand electricity, you understand, what comes to your mind is voltage and current. Okay, these are the basic things about electricity, and these are the two basic parameters that makes up electricity. Okay, so voltage is what pushes electricity through a circuit, which is the driving force. Now, for those of us who doesn't have electrical background, I'm not an electrical engineer, but by training and by reading and by studies, I've come to understand electrical system very well. So I can speak to this. Now, I want, for those of us who are not yet very familiar with electricity, I want you to consider electricity as a water that is flowing through a pipe. A water that is flowing through a pipe. Now, the pressure, the pump that pushes that water is what we know as voltage. The water itself is what we know as electricity. So we don't consume, sorry, the water itself is what we know as amperage or the amps. So we don't consume voltage. What we consume or what we use to power our equipment is amperage. Okay, the voltage is just the force that pushes that water. So this is an analogy that I just wanted to use to understand when we're talking about electricity. So we're going to be talking a lot about voltage and current. Okay, so I just wanted to use that to understand this. So the voltage is what pushes electricity through a circuit, which is the driving force. And of course, the current is what is pushed through by the voltage, which is the flow. Electrical power is when voltage and current work together to do something useful, such as to turn a motor or to light a lamp. Now, electricity is measured in watts, just like we talked about power, which is measured in watts. Now, watts is equal to voltage times amperage. Voltage times amperage times power factor. Now, this is the real power. The real power. There is also what we call the apparent power, which is VA. We'll come to this, but just know that there's what we call real power and there's what we call apparent power. So apparent power, the only difference between real power and apparent power is that there is no power factor. You don't have to deal with power factor. We're talking about apparent power. Okay, so when you're paying for your electricity bill, ideally, when you're paying for your electricity bill, you should be paying for this, your apparent power. Okay, ideally, this is what you're going to be paying for. So let's talk about single phase AC electrical system. Of course, we should also understand, even though I didn't speak about it here, we should also understand that electricity exists in two forms. We have direct current and we also have alternating current, which is AC. So the most common form of electricity that we use in our homes or in Nigeria, even around the world, the most common form of electricity is the AC, which is alternating current. So we're going to be dealing with alternating current in this training. But just also that you are aware that there's also another form of electricity, which is DC, direct current. So we are talking about single phase alternating current electrical system. So this is a power system having only one sine wave, and the frequency of that sine wave is 50 or 60. Now in Nigeria, we're using 50 hertz. America uses 60 hertz. So it is country dependent. Okay, so this is just a figure representing what a sine wave is. It's an alternating, meaning that it's alternate. So this is just how the name comes about. It's alternating. And it's a single phase alternating system. So for example, in most homes or small buildings where only single phase electrical systems supply the electric power, the voltage is Nigeria uses 230 volts for a single phase, which is 230 volts for a single phase. Now, this single phase is basically common for small appliance, for small homes of small residential buildings. That's where you find single phase electrical connections. There's another one, which is the three-phase electrical connection. We'll come to that, but just so that you understand that what powers most of our household are single-phase electrical system. So we also have the three-phase electrical system. So this is a power system having 3 sine waves, and the frequency of each sine wave is either 50 or 60. I've said this before. In Nigeria, we use 50 hertz. The 3 sine waves are separated in time with a phase angle of 120 degrees. So if you look at this diagram, you're going to see that each of these, the red, the yellow, and the blue line, they are separated by an angle of 120 degrees. So from here to here is 120 degrees. From here to here is 120 degrees. And from here to here is 120 degrees. So this is a 3-phase system. There are equipment that uses 3-phase. Okay, so there are some industrial machines that you need to connect the 3 phases all together to that equipment. And for most of the equipment that we use in our homes, it's just a single phase. So it's just one phase that goes into them. So these are the different applications of single phase and 3-phase equipment. So let us talk about power quality. Power quality is related to how well an electrical system maintains a pure sinusoidal waveform at rated voltage and frequency. At rated voltage and frequency. So power quality is talking about the relationship between voltage and amperage. These two things are very important. Voltage is talking about the relationship between them. So power quality issues involve all momentary phenomena, including spikes and voltage and outages, as well as harmonics. We're going to talk about harmonics as well. Modern electronic equipment both causes and is affected by the problem of power quality. So power quality is becoming one of the most important issues in energy management today, because if your power quality is bad, it's going to affect a lot of things. It can blow out your machines. It can affect your equipment. It can also lead to death. So it's important that we also, as an energy auditor, though not mandatory, but it is important that we also pay attention to the power quality of the facility that we are auditing. So let me talk about harmonics. I made mention of it in the last slide. So harmonics are distortions of the normal electrical current wavelengths generally transmitted by nonlinear loads. I will explain that further. So in other words, harmonics are a multiple of fundamental frequencies. If the fundamental frequency, I think there's an illustration here. Okay, so now this is a fundamental frequency. The diagram here is a fundamental. So this is a normal frequency. It's normal, it's pure. There's no distortion. So this is how your electrical frequency should look like, whether 50 or 60 hertz. This is how it should look like. But when there is a distortion to this frequency, when there is my cursor. Okay, so when there's a distortion to this, so like you can see now, the red one is your normal waveform. Okay, so if there's a distortion, which is this kind of gray one that you're seeing, if it comes and there's a distortion on it, okay, instead of going one full cycle here, it now forms like two, or more than one cycle here. Okay, so once this happens, the actual waveform that you're going to have is now the blue one. You are going to see this blue one. So instead of completing one full wave like this, you're not completing like 3 or 2 rather. So that's what I try to explain here. In other words, harmonics are a multiple of the fundamental frequency. If the fundamental frequency is 60 hertz, the second harmonic is 120. So the second harmonic will double it. The third harmonic will triple it. And the fourth harmonic will make it 4 times. Okay, so that's what this. So if you look at what we have here, this is third harmonic. What we're having here in this diagram is third harmonic. So this is the first one, this is the second one, and this is the third one. Something that should have gone only for just once is not going, the harmonics have made it triple. And this is what we call harmonics. So when these are induced into your electrical system, it affects the power quality. So this is what harmonics is all about. So now this is the fundamental frequency that we have, undistorted. Now this is the process of distortion, and finally this is what we have. So this is a sick wave. You can see how that it has been distorted. So this is harmonics that has caused this. So harmonics are generated by solid state-based equipment that converts AC line voltage to DC, such as, remember I said that we have 2 forms of electricity. You have the AC, alternating current, and you have the DC, that direct current. So for some of the equipment that we have in our homes that converts the alternating current to DC current so that our appliances could use those forms of electricity, these are the things that, these are the equipment that induces harmonics into the electrical system. So what kind of equipment do we have that does all of this? So you have switching power supplies in our PC. We all know that our personal computers, laptops, they use direct currents. These are electronic components that use direct currents. But what you're feeding into the laptop is an AC current. So there's a switching circuit that does it, that converts from the AC to the DC. So this switching induces harmonics into the system. There are DC drives. DC drive means, as the name implies, they use direct current. So when they're now switching from alternating current to direct current, they induce harmonics into the power system. We have our variable frequency drives. all of these are systems that use direct current, but you're supplying an alternating current to them. So they have to convert that alternating current to direct current. So in the process of that conversion, they induce harmonics into the power system. So most power systems can accommodate a certain level of harmonic currents, but we experience problems when harmonic becomes a significant component of the overall load. As this higher frequency harmonic current flows through the power system, they can cause communication errors, especially now we're talking about Industry 4.0, you're talking about cloud computing, you're talking about Internet of Things. So some of these things are connected to the power system. So when there's a harmonic into the power system in which these things operate, they can also cause communication errors. They can cause overheating for hardwares. They can cause overheating. They can also cause metering errors. So total harmonic distortion is a measure of power quality. So when you go out, when you plug in some equipment to measure the level of power quality and you're seeing the readings, so the readings for harmonics you're going to see is the total harmonic distortion, which is the measure of the power quality. So harmonics can be corrected through they can be corrected through harmonic filters. So let me talk about voltage now. I'm going to talk about voltage with respect to imbalances in the voltages. When I talk about voltage imbalance, this is only applicable to three-phase systems. So you have three phases, you have the red, the yellow, and the blue lines. If the voltages across these three phases are not balanced, and remember that these three phases can be going into one single equipment. Okay, so when there is voltage imbalance, it creates problem for this equipment. Okay, so how do we calculate voltage? How do we know there is a voltage imbalance? So I'm going to walk us through that. So problems can occur because of voltage imbalance between three phases. Please, I don't know, somebody has unmuted himself. You've unmuted yourself and the noise. Okay, thank you. So problems can occur because of voltage imbalance between three-phase systems. Now, this can be a serious problem in motors. Remember, most motors, especially industrial motors, they use three phases. So when there's voltage imbalance, it creates problems in the systems. So the percentage voltage imbalance is found as the ratio of the largest face-to-face voltage. I take that again. Percentage voltage imbalance is found as the ratio of the largest face-to-face voltage difference from the average, divided by the average voltage. Don't worry, we're going to illustrate this. That sounds like a long sentence there. So for example, if we have 220 volts, 215 volts, and then 210 volts, remember that for Nigeria, our standard voltage, our standard single phase voltage is 230. So for these voltages that I'm mentioning, none of them is even up to the standard voltage in the Nigerian system. But of course, you know, the kind of system that we operate, in most cases, you're not even going to get up to 230 volts. But this is a typical example of a voltage across these three different lines. So you have 220, 215, and 210 volts. Now, first of all, we have to calculate the average voltage. Calculating the average voltage means that we'll have to add all these voltages and divide them by 3. So we add 220, 215, 210, we add them all together and they will divide it by 3, and they will have the average voltage. If we have this average voltage, the next thing we are going to do is to find out the voltage difference. The voltage difference. So if we minus 215 from 220, what do we get? 5. So the voltage difference for the first line is 5. The voltage difference from the second one, 215 minus 215 is 0. And then the third one, the voltage difference is 210 minus 215 is minus 5. Now, the positive or negative is not relevant because it is alternating. Okay. So if we have been able to establish the voltage difference, first of all, we calculated the average voltage and we now establish the voltage difference. Okay. Now, the next thing we are going to do is we are going to divide the line with the highest voltage difference. So if you're looking at this very one, we have 5, I will have minus 5. Both of them are the same. Whether minus or negative, it is irrelevant. Okay. So this is the highest voltage difference. We divide it by the average voltage, which is 215. Once we divide that, we'll have our voltage imbalance, which is 0.023. If you multiply this by 100, you have 2.3. So the voltage imbalance in this system is 2.3. And this is how to calculate voltage imbalance in a three. When we will talk about voltage imbalance, we're talking about three-phase system. It's not like voltage imbalance in a single-phase system. So it's for three-phase systems. So here's an example. If we have 400 volts, now when we're talking about three-phase system, okay, I think I made mention of when I was talking in the other slide, I told you that our standard voltage is 230. Now that's for a single-phase system. Now for a three-phase system, the voltage is 400. Okay. That's for Nigerian system, it is 400. In schools or in our practices, we would have been taught that it's 415. Okay, but that is, I think that is an error somehow. I don't know how it came to be, but our standard supply voltage for three-phase system is 400. So if we have a system that is 400 volt, 385 volt, and then 409 volt, the voltage imbalance is equal to the maximum deviation from the average divided by the average voltage. I think I've explained all of this, how we did our calculation. And just here's another example. The average voltage between these whole phases is 400, 385, and 405. We divide it by 3. I will have our average voltage, and we can calculate the voltage deviation from each one of them. We have the first one is -2, 13, and -11. So 13 is the highest. So we divide 13 by the average voltage, and they will have 3.3. So this is just how to calculate your voltage imbalance. Okay, so this is just another example. On your own, you can solve this these examples. The answers are there. So what are the problems with imbalance in voltages? If there is overvoltage beyond the standard voltage, if there's overvoltage, it can cause electrical equipment overheating, it can cause electrical circuit failure, it can reduce the equipment operating life, it can also cause production and operation impact. So if it's under voltage, it can also cause similar thing to almost the overvoltage, like lack of sufficient power to. Now, if there's under voltage in your system, you have insufficient power to operate your electrical equipment. That's why when some people they say they have low current, not necessarily that they have low current. What they have is low voltage. So the low voltage is not pushing enough current to power your electrical systems. Okay, so if there's under voltage, it might not be able to power the equipment. So that's one problem with over voltage. It can also cause electrical circuit overheating. It can cause reduced motor torque, motor overheating, reduce equipment operating life, and also production and operation impact. So let's talk about power factor. So power factor indicates how well the current and voltage are working together. Remember I told you that when I was introducing electrical energy, I told you that we'll talk about electrical energy, we'll talk about current and voltage. And I told you that these two are like husband and wife, they work together. Okay, so power factor is now also telling us how well their relationships are, or their relationship is between the voltage and the current. So a number of 0 to 1 is used to represent power factor. And then power factor is equal to real power, which is the kilowatts, divided by the apparent power, which is the kVA. Apparent power, the kVA. Okay, so the ratio of how much of the power, so power factor is the ratio of how much of the power supply that can be used to perform useful work. Okay, so power factor is dependent on the type of load in the electrical system. So you cannot describe power factor until you know the equipment that is using the energy, the power. Right? So that's what this is talking about. So depending on the kind of equipment you have, you could have resistive load, you could have inductive load, or you could have capacitive load. We'll get to that anyway. So power factor reduces the amount of useful power. Power factor reduces the amount of useful power. So what you're getting is kVA. When you now consume that power, it now becomes kilowatts. So the amount of useful work that you do is the kilowatts. So power factor is the difference between these two. So power factor reduces, what you're getting to the actual power. So kVA is an apparent power. That is what you pay for. Kilowatts is active power, power that performs the work. There's another one, kVAR. This is reactive power. Okay. Now does not do, and this does not do any useful work. Okay. This one increases when there is a quarrel between these two. If there's a quarrel between these two, and depending on the level of the quarrel between these two, this one increases. Okay, so this one comes in. So let us use the beer analogy to explain this. Okay, so remember I told you about the kVAR, and I told you that when there's a quarrel between the kVA and the kilowatts, then this one increases. So the more this one goes up, the more the kVAR increases. If this kVA comes down to the level of kilowatts, then this one does not exist. Okay, so if we understand this, now let us look at the diagram here, the beer here. Okay, if you pour a beer in a glass, you can see this, the beer here is the real power. This is the reactive power, which is wasted. Okay, now what you're paying for both the foam and the real beer. That's what your apparent power is, your kVA. That's what your kVA is. Okay, so we're going to explain this further with a mathematical principle. So before we get to that mathematical principle, let me talk about the load. Remember I told you that power factor is determined by the load or the equipment that is consuming that power. So let's talk about resistive load. Okay, in an electrical system, volts and current both ideally have a sinusoidal waveform. If the current and the voltage waveform are aligned and reach their maximum amplitude at the same time, the current is said to be in phase with the voltage and no kVAR are present. Now, this is current, the black one, and the red one is the voltage. Now, look at their maximum amplitude. The peak here is their maximum amplitude. So you notice that here, both of them reach their maximum amplitude at the same time. So when they reach their maximum amplitude at the same time, then it means that no energy is wasted. kVAR does not exist. So they're in perfect harmony. So there is no kVAR. So example of such load are electric heaters, geysers, and incandescent lamps. These loads do not reduce power factor. They allow voltage and current to work together at 100% power factor. So this is a resistive load. So whenever you have a resistive load, power factor is unity. Power factor is 100% whenever you have a resistive load. And I'll give you an example of what resistive loads are. So let's talk about the network, which is an inductive load. However, if voltage reaches its maximum amplitude before, if voltage reaches its maximum amplitude before the current, kVA are said to be lagging. Now look at this diagram. You find out that this is a voltage. It gets to the maximum amplitude before the current. So you find out that in this case now, the voltage is lagging. Okay, it's lagging behind. The current has now shifted. They are no more in perfect harmony. So in this kind of situation, there is power factor problem. And this kind of example of this kind of systems are motors. You go to industries, that's why they always hammer on power factor problems, because they have industrial motors that actually reduces their, that actually increases their power factor, rather actually reduces their power factor. So motors, transformers, load with coils. So the magnetic field in this system causes the current to slow down. So this is an inductive load. So it creates a problem. It causes the problem of power factor. So let's talk about capacitive load. So in other hands, if the current reaches its maximum amplitude before the voltage, kVAR are said to be leading. Now this is an illustration. You find out that the current first of all reaches its maximum amplitude before the voltage. So in this case, it is leading. So the voltage is leading in this case. Okay. So example of this load is the capacitor. capacitors. Okay, this is an example of load that causes this kind of effect in an electrical circuit. So this load increases power factor. It increases power factor. Remember that inductive load reduces power factor, but this one increases power factor. So ideally, if you want to correct the problem of an inductive load, which reduces power factor, what you need to do is to add capacitors to the system to increase the power factor. So as a way of correcting power factors, we have to introduce capacitor banks to correct power factor. And that's why when you go to the industry, well, anywhere you want to correct power factor, what you need to do is to introduce capacitors. You use that to correct the power factor. So let's now look at the more like a mathematical principle in calculating the real power, the apparent power, and the kVAR, the reactive power. Okay, so I want us to still go back to our secondary school mathematical principle that we use Pythagoras theorem. Pythagoras theorem. So in Pythagoras theorem, we have what we call SOHCAHTOA. SOHCAHTOA. This is sin theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and then tan theta is equal to opposite over adjacent. So if we apply this SOHCAHTOA, we can calculate, we can solve any power factor problem. You know, if we apply this, we can solve any power factor problem. Just draw this triangle. Know that this is your apparent power, this is your real power, and this is your reactive power. Now, depending on what you're given, if you draw this triangle, you can plug in the values that you're given, and then you can now use this relationship to calculate whatever is unknown or whatever you're asked to calculate, whether it is the cos theta, which is actually the power factor. Now, in this triangle, your power factor is equal to your cos theta, which is the angle here. Cos of whatever angle here is your power factor. So let us look at an example. If true power is equal to 700 watts, and cos theta, which is your power factor, by the way, is 45.6 degrees. If you now point cos theta, cos 45.6 degree in your calculator, you're going to get 0.7, which is 70%. What is the apparent power? What is the apparent power? So you're not looking for the hypotenuse in this case. So our solution would be true power is equal to, now if we look at this diagram, so true power is equal to VA, which is your hypotenuse, times cos theta. This is your cos theta. So if we deploy this formula in that example, if we deploy this formula, we'll be able to calculate what VA, the apparent power, is. So if we make VA subject of the formula here, we are going to have the power, which is 700 that we are given, divided by cos theta. So if you do that, you're going to have, there is 700 divided by 0.7, you're going to have 1000 VA. So this is your apparent power. Your apparent power is 1000, but your real power is 700. So you're wasting 300 watts. Okay. The difference between this 1000 and 700 is 300. That's what your waste is, but you're paying for it. So that's the difference between apparent power and real power. So I think I've explained this before, power factor correction, where I told you that you use capacitors to correct power factor, because what actually causes power factor is when you have inductive loads. It causes the problem of power factor. So you use capacitors to correct it. So let me now explain to us how we now size capacitors. If there's a power factor problem, how do you now size it? How do you know the size of the capacitor to correct that power factor problem? So to know the size of kVAR, this is reactive power. kVAR is the reactive power. So to know the size of kVAR that is needed to correct the power factor problem, you need to know the real power that you're actually consuming. Then you multiply that by a table factor. There is a standard table factor. You can find it online. I will show us one in this training. Okay. Just a minute. Some people in the waiting room.
Mr. Facilitator, I hope you are noticing the time.
Yes. But
yeah.
I just
So
mentioned to
there
you.
are loads of questions that are needed to be asked.
We're stopping in the next 5 minutes.
Okay. So in the next
Summarize the 5 minutes. Actually, we'll continue next 10 o'clock next week. Will not be compromised. No waiting for anybody. 10 o'clock, you continue from where you stopped exactly today.
Exactly. So
after then, I'll conclude what I did yesterday, what I did in the morning.
Thank you very much for pointing out the time. So once I'm done with this example, we're going to stop and continue. Are needed at a given load is needed, then the real power. Hello, can you hear me? Okay, so I take it back. So the real power is also needed, and you also need to know what your desired power factor is. So for example, if you come to a facility and the power factor is 70%, okay, and you want to correct that power factor to 90%. So you need to know the actual power factor of the facility, and you need to know the desired power factor. So if you know this and you know the real power, you use a table, such as the one in the next slide. That is a table factor to actually find what your kVAR should be. So let me just quickly get to that. So this is what we call table factor. So this is your desired power factor in the horizontal axis, and you have your original power factor in the vertical axis. So all you need to do is to come here, look for the actual power factor that you have, the original power factor. So assuming you have 70, you have to trace it horizontally up until the power factor that you desire. So assuming you desire 90% power factor, which is here, you have to look for where they coincide, which is this, and the value here is 0.536. So multiply this value with the real power. Once you do this, you have your kVAR. It's a simple thing. Okay, so let me just solve this. Let me just walk us through this simple example. So a facility is operating at a power factor of 70% with a real power load of 200 kilowatt. And the real power is 2,000 kilowatts. How much corrective capacitance in kVAR is needed to improve the facility power factor to 90%? So we have our different options here, but let me just walk us through that. This is similar to what I explained earlier. The power factor that we have, original power factor is 70%, but we want to increase it to 90%. So the table factor here is 0.536. These are our table factor. So we'll take this 0.536 and multiply it by 2,000, which is our real power. So kVA capacitance is equal to real power in kilowatts times the table factor. Now our table factor at 90% is 0.536. So if you take that and multiply it by 2,000, 0.536 multiplied by 2,000, you have your kVAR, which is 1,072 kVAR. So the answer is D in our question. So the answer here is D. So I think I'm going to stop here. So these are test questions. You can attempt them when you have these slides. So, but I think I'm going to stop here, and then let's take questions. We have to stick to time. I'm sorry for overshooting the time by a few minutes. I think it's fine to leave it here, and then we'll listen to questions, comments, and contributions. Thank you very much. Engineer Oshe. Engineer Oshe, it seems you...
I can hear you.
Okay. So at this point, we have to take questions, right?
Yes.
Okay.
Yes. My name is Engineer Oshoba. Adesoji Oshoba is my name. I'm the Technical Secretary of NIEEE Abuja Chapter. Thanks for your presentation, Engineer Chima. And also thanking you for this elementary part of your presentation. But however, I just want to quickly point out some issues, some things that I picked up in your presentation. Probably others too may also ascertain what I'm talking about. In your presentation, in one of those slides, I think about 3 to 4 slides before this last one, you were talking about the real power and the apparent power, what is being paid for. In electrical calculations or in terms of billing, you actually pay for kilowatt hour. So that is, you are paying for real power, not the apparent. You are paying for the real power. So that is why when you look at your bill, you are going to see kilowatt there. For the domestic load, there you are going to see the kilowatt hour. But for industrial load, there's a way that they do compute it in terms of their billing system, where you may not see the kVA. You know, they normally refer to the kVA as the infrastructure billing system. So just want to correct the notion that you pay for apparent power. We actually pay for the real power, which is the kilowatt hour. That is that. Then one of the reasons why we are using 400 volt is according to the NEMSA guideline. It's not as if there's no 415 or say 420, but NEMSA has given us the guideline to follow that we should use the 400 volts. So that is why the design calculation will always be based on 400 volts in terms of the NEMSA guideline. And of course, you made mention of some codes. Thank you for this, gathering of knowledge. I want to stress that the Nigerian engineers need to get involved with codes. You don't do designs without using these standard codes. In Nigeria, there is what we call the NESI standard. Nigerian engineers need to imbibe into or buy into the culture of using this NESI standard. I know there are 76, 71 out there. There is high triple E's, 17, 16 edition, but they have a NESI standard that can give you as a guide. It will give you as a guide so that when you are doing your design, you will be able to, do the right thing. Just as I said, there are a lot of things that we are getting into in terms of this energy audit. Thanks for these basic design calculations. I want to employ engineers to get used to dealing with these calculations. They are very, very important. I've been trained as an auditor in South Africa, and I can tell you, these are some of the, formulae that we use in coming up with, auditing in terms of when you are doing the manual inputting. But however, there are power analyzers that will do these things within a week if you plug it in, and all this formula there and there, you are going to see it on the equipment that will actually tell you what is the VA for that system, what is the kVAR for that system, and the rest of the information is updated. Thank you, Engineer Chima. Appreciate it.
Thank you, Engineer Oshoba, for your wonderful contribution. Let me just respond. Let me just respond to excuse me. Sorry, just a minute. Let me respond.
Okay,
to this.
make it brief.
Yeah, I'm going to make it brief. First of all, you talked about what we pay for. That we pay for kilowatt hour. Yes, you're absolutely correct that we pay for kilowatt hour. But in my presentation, I say ideally you're supposed to pay for kVA. If you are paying for kilowatt hour, then who pays for the power factor differences? By the virtue of the kind of equipment that you use, you're inducing losses for the providers of that electricity. If you go to the standard country in the Europe, in the America, they charge you by kVA. What comes into your house is kVA. That's what you should pay for. But in the Nigerian system, because we are still emerging, we are still in the nascent phase of our development, these power factors are being neglected. Even in the industry, they don't pay power factor charges. If you go overseas, they penalize you if your power factor is bad because the providers of those electricity are losing money by your bad power factor. So it's when I say that we pay for kVA, in ideal situation, you pay for kVA. It's just that here in Nigeria, we pay for kilowatt hour. We pay for the kilowatt that we consume. So it's a kind of a little bit complicated issue. So let us not begin to complicate these issues at this stage. If you go to tariff design, we can talk about that. Then you're talking about the 400 volts. The 400 volt you're talking about, you say it is from the NEMSA guideline. Yes, I totally agree with you. However, NEMSA does not formulate code. They are only implementing the standard. So we have this in the grid code. This 400 that we are talking about is in the grid code, is in the distribution code, is in the transmission code. So names are just picked it from the code and they make it known because it looks like we don't know about this in the past until NEMSA came on board. So thank you very much. I just quickly want to add this to what you've said.
Okay, thank you. Thank you, everybody. Hold on. Thank you, everyone. At the beginning of the training, I said we have limited time. And one thing the technical secretary have informed me is that we just have to end this class at exactly 1. So I want to crave our indulgence. If you are going to share something different from what have been said, good. But if not, and I'm limiting everybody to just 30 minutes. The presentation will be sent to your email, Ndoka. That is no problem. Everybody's going to get the presentation. You're going to get everything, please. Somebody, Odunayo, you have less than 30 seconds, please. What do you want to say, sir?
Good morning, everyone. Good afternoon. My name is Engineer Mrs. Odunayo Bamodu. I wanted to say something because I'm into high PP, and when we bill our customers, we give them bill and we do our calculation in kilowatt hour. So that's why I just want to support what Engineer Soji Oshoba said, that we do our calculation. So me as an IPP vendor now, are you saying that I'm running at a loss for giving bill in kilowatt hour? I just want to know.
Okay, let me speak to that. Let me just speak to that quickly. Now, how do you calculate your kilowatt hour, which is the active power times the number of hours that the person uses those equipment, right? So who pays for the power? If the power factor is, for example, 70%, which means what you're throwing into that facility is 100 kVA, but because of his inefficient equipment, he's now using only 70% of it and wasting 30%. Who is paying for that 30%? That's the question.
Hello, sir. Please,
okay.
Can you hear me, please?
Can we?
I think the confusion here is simple.
Who is speaking?
You guys, my name is Ibrahim Hussein Al Hassan. I'm from NDPHC. But the problem is, I think you are like
okay,
interchangeably using power and energy. You understand? Kilowatt hour is a unit of energy, not power. As I think both of you explained earlier. So what we are buying from utility companies is not power. What we are buying from utility companies is energy. Then the rate of utilization comes in later. So, but if we did not like try and maybe get these two things straight, we'll just be going around about arguing about this reactive power.
Okay. Let's not go into
let's not go
the
into
nitty-gritties of this. Yeah, let's not go into that. We'll come to that, please. Let's not go into that. We'll come to that. Maybe perhaps there need to be a little more awareness and education on this. Yeah, energy, but let's not go. I think in our further training there may be a point where we'll have to talk about tariff design and all of that, where we can now talk about maybe how billings are being done and all of that. But let's not mix up issues. Just know at this point, for Nigerian situation, we charge kilowatt hour is a single unit, single system tariff design that we're using. If you look at the power, the electricity bill of someone from Kenya, you'll be amazed what you're going to see. If you look at the electricity bill of someone from Europe or America, you'll be amazed what you're going to see. But let us not go into all of those technicalities. We'll come to that and deal with it later on.
Okay, thank you, Engineer Chima. Let me speak like a layman. What we pay is for energy. There's nobody talking about, we are very clear about the difference between kilowatt, which is power, and energy. What we are now saying is the wasted energy, who pays for the waste, which is kilowatt, which is the apparent power. So if you look at that triangle, we have the real power, we have the apparent power. So let's leave this, and maybe by next week, we're going to start with that discussion. So next week, I'm going to open the platform by 9:45. Please, I want us to make our time and do some research. From what Chima said, that ideally, you have to pay for your losses, you the consumer. While Engineer Desoji is saying, somebody somewhere we don't know is paying for those losses. They are charging you basically what you're using, irrespective of whether you're using inductive load or any other load. So let's leave that. Let's not go into that. I know many people have questions, but one thing I have said is that we have 10 minutes to go. At this point, I would like to welcome the chairman of NSC, Maitama, which is a partnering organization for this training. He's going to say one or two things for 2 minutes or so. then we can now continue with the question and answer session. But I can guarantee you before 1 o'clock, I'm going to close this class and I'm going to stop the recording. I think at this point,